Hello and welcome everybody to this Quake Champions lag fix. I want to introduce myself. I am Mark HTML. I am the guy behind the Quake Champions lag fix. Um, so I know I'll have a few questions, but before we do that, let's go ahead and see some gameplay of a game that I played. I'm going to show, I don't know, probably like 2 or 3 minutes of the gameplay to show you how smooth it was. Keep in mind, I am using OBS, and my graphics card is a mid-class system. I have a mid-class system, which that means I don't have like a high-class or an ultra system like some of the most amazing people do with like 1080 GPUs and stuff like that. So I'm around the mid to low class range. So
None can stand in our way.
Prepare your team. Round begins in 3, 2, 1. Fight. Teams are tied.
Warning.
Lead lost. Teams are tied. Lead lost. Teams are tied. Lead taken. Lead lost. Teams are tied. Impressive. Lead lost.
That hurt.
Teams are tied. Lead lost. Teams are tied.
I will kill you.
Lead lost.
wow.
Incoming quad.
Please remove.
Quad spawn. Enemy has the quad.
Sad for you. Mob is the flesh of the fallen. That will be ours. I will need repairs after this. Destroy the filthy human meat.
Alright, so thank you so much for watching that video. If you did and you're still here, I really do appreciate it. Sorry for like the intervene of the video. I know people want to get like straight to the fix. this is kind of going to be a longer video because I've got a lot of things I need to kind of declare and kind of throw out there. That way people are not like sketchy about, yeah, right, like a Quake lag or Quake Champions lag fix. Like, really? Like, come on. There's tons of those on YouTube. I want to declare this is a legit lag fix. This is not like some fake shit or any like troll attempt. It's none of that. So this Quake Champions lag fix, before we get into it, there's been other lag fixes. People have done stuff like going into the NVIDIA control panel and removing this and removing that and changing this setting and changing that. Some people have said I've also had a fix out there for external kind of open source programs that you can use on the side to boost your system. Really what that does is it allows, most of those tools are taking Quake Champions and prioritizing it on the CPU and GPU. Nothing else is being prioritized at that moment. It's priority. It's number one. The others are the childs, the secondaries. And this program also kind of like goes through the temporary folders like anything with like cleaning up your system, removing temporary files, shit like that can help performance of your computer. Remove any malware that you may have on the computer, remove any viruses, and you get a little bit of boost. Update your drivers, blah, 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 you get boost. Well, this is kind of simpler than that. These are external programs to kind of do these little tweaks in behind your OS system where it allows you to get so much better FPS. But that's not fixing the video stutters and the game freezes, the hit detection issues, the jumping from one pace to another pace automatically. Like, what the hell? How did I get down here? You understand if you've had those, that kind of moment, like what? So I want to declare a few things before I jump into this fix completely. This is a hard-coded Quake Champions lags fix. This is not something where I'm using an external program or I'm messing with the CFG file or I'm doing this or doing that. This is legit hard-code lag fix. So this is a complete coded, hard-coded shit. And a disclaimer also, I've had 12 people that I've sent this build to. A lot of them have been IRL. There have been a few on Steam and a few on other websites. I've had great feedback for them. Keep in mind, this Quake Champions lag fix is also for low and mid-class PC users. So if you have something like a 750 GPU with an i5 processor or like a 950 or a 980 GPU with like an i7 or something like that, or somewhere in between from 750 to the 900 series, this is videos for you. Because this is basically what the November patch supposedly is going to fix for mid-class and low-class users. So if they succeed to that, just ignore this fix. But if you're still having problems, you're welcome to come back here and try this fix out. Right now, I've released it to people to beta test, but I haven't really publicly released this. You can go on a Reddit page where I posted it and try it for yourself. I've had one guy that is criticized every last bit of it, but he's one person that says it didn't work for him and 12 people that have come back with amazing results. They can't believe it. Even if they can only get their game to play at 40, 50 FPS at low settings, it's stable. They don't have any lag spikes. Hit detection's flawless. The video stuttering's gone. The game freezes are gone. The jump pacing is gone. I mean, they really, really, really enjoyed it. And it's a really simple fix that doesn't require you to do anything but drag a folder into your actual Quake Champion Steam directory and boom, you're ready to go. But I've done some different code the last 2 days, and the little installation there's one more step you got to take, but that doesn't mean anything. Now, also, disclaimer to any users that are wondering, is this going to ban me from Quake Champion servers? No, it is not going to ban you whatsoever. This is something that Quake Champion server, it can't detect. It's a simple fix. There's nothing to it, and that they're not going to ban you for that. So don't even worry about that. I've had 12 people. I mean, they've had 3 people out of those 12 that is crazy hardcore Quake Champion players that play every single night, 8-10 hours a night, and says that the fix is unbelievable, that they're having so much fun playing it, and they couldn't thank me enough. And I'm happy for that. That was set out for my goal. So November patch is going to come out, and I have high hopes that they'll pull it off. But I feel like they still won't fix it because they are prioritizing the game for high end to to ultra user people's builds, like the high class, the ultra class people. With people like 1060s and 1080 GPUs with i7s or i8 GPU or CPU, excuse me, stuff like this. Like people are those are the people they're prioritizing the game because these people don't have any issues. They're fine. You could upgrade your whole hardware, but a lot of people don't have the money to do that. And now I've had a few people like scrolling the Reddit posts that say that they have a high-end PC or ultra-end PC and they still have video stutters. So, like I said, it may be a complete fix, but it may not be on Bethesda and its software side. My side, it's for low and mid-class PCs. And it would probably get amazing results for a high-end PC. I'm planning on upgrading my GPU this Christmas, so I'm going to go from a 950 series to 1080 series with around 8 gigs of video memory. So I'm super excited. I'm going to have a lot of room to mess around with performance and optimizations for other great games in the future. But okay, so enough talk of that long intro. Excuse me for that. So let's go ahead and jump into this. So the first thing is, what is this fix? What is specifically, what have you added before and what have you added now? Right now, this fix is I've took all of the Quake Champions OpenGL functions and prioritize each individual of those functions to and put those in their own threads. Okay, so for example, if you've heard the terminology or term multi-threading, okay, you're going to get this really easily. Each GL function is in with its own thread. Okay, so each thread carries its own GL function. And what I've done is I've put an if statement in for that specific doing. So let's go ahead and jump in so I can explain to this a lot more easier. So we'll go into the main code file. Okay, so the first thing here is, now if you look at my code, you're going to see this one specific line. This file underscore reader does not have anything returning to it, so I was messing around with some code at the time. I haven't actually fixed this yet in the new code, but this is I was trying to new ways to read compressed files, stuff like that. Then hopefully maybe Quake Champions would kind of read those compressed files. If so, I didn't have any luck with that the last 2 days, so I just put that on a hold. That will be out of the build in the new code most likely. So the max threads that we can have is actually we actually have 1 million threads or 100,000 threads. This counter, it's going to say that it can do 100,000 threads or 1 million threads, but really in reality's sake, a GPU could have 10,000 threads simultaneously working at once and not have to worry. And more than that, CPU can hold as much as that, but there's not that many threads in here. So there's somewhere around, I don't know, maybe almost 60, 70 threads total. It's just nothing to that counter. But this allows me to put a number here so I don't have to worry. This program will know this is how many threads it could be using. So the first thing we're going to look at is we're using the dword when API, and we're calling our thread underscore graphics, which is I call these methods. Now I may call this different to what you professional programmers call specific things, but just excuse me for that. I make up my own names for shit because that's just the way I remember things a lot better. I need to get out of that habit, so my apologies if I say something that you say something entirely different name for it. So this method here, thread underscore graphics, this I will probably go ahead and take out. I don't need this one line here. But if you look, we have thread start. Okay, this goes through our entire thread. We have a lot more code here at the end that's calling each and one. We're using each variable from OpenGL in here, or each function in here, so to speak, from OpenGL, from actually taking the actual DLL, which is in the Quake Champions. Let me see if I can pull this up for you and show you. this DLL right here, where you're taking these GL functions from that. I'm using IDA Pro to look up these functions, so that way I can write these down and be able to use those within code. So just to keep that in mind. That's how I got the actual GL functions and variable names they used for each one of their codes. So this is an example right here, okay? We're using draw thread _1. This is not in a class, but we have our classes for each individual one down below. I'll talk about that in a minute. Each one of these have a few variables called start, thread, time, minimize, maximize, thread call time, seconds, and that's our main point here. And then we'll say, yeah, we already say minimize and max, but anyway, if we say draw thread 1 is equal to time, then times the thread call time, times minimize, times the actual function name, plus the seconds, we want to equal this to 0.1, so that's half of a second. If I could change this to milliseconds and do this a little bit different where it would go by milliseconds, but we don't have to do that. And if you look here down below, we've added another one. The reason why that I've added the same thing is I've added speed in here as well. So it's 20,000, which means it's going to go really it's 0.2 seconds. If you be really technical, it's not 20,000, it's 0.2 seconds. That's how fast the actual thread is going to go. And in terminology, that's probably not a good mathematical approach, but it seems to work pretty great for me. Then we call, instead of time up here, we call max times the thread call time times the minimum times the actual variable or function name plus the seconds plus the speed equals to that specific doings. Then draw thread 1 is equal to pause is equal to false. So we don't want this thread to pause in any way, shape, or form. The reason why I put this in here is in that actual glass DLL that is in Quake Champions, it already calls a pause and then a resume in the threading. They already do that. So if it's going to use this code and it's going to call these threads, I don't want any of these threads to be paused, because it will actually override and force these to pause. It's just the way they have this hard coded in there over there at id Software. So I have to put a pause equals to false, so that way my threads are not going to pause. And then basically draw thread equals fast underscore draw, or fast underscore draw thread 1 is equal to true. This will get our max speed of up here from our variable in here, which is actually in here as well. We do the same thing on draw thread 1. Each thread handles each one, but this one's a little bit different, but it still uses the same amount of code here, but it doesn't call the pause method. So if we use draw thread 1 equals to true, so we're using 1 is equal to true, 0 is equal to false. So if we call this and we want this to be 100% true value of what this if statement is going to do, we're going to call a 1 and call an equal to true of this actual thread. This is basically, I do the same thing for this all the way down through each individual GL function. Everything is basically the same all the way down. Now you're probably asking, what in the hell? But it's my method. It's the way that I done things, and it's just it. So if you look at this too, we're calling draw thread 1 equals to time times the thread call time times minimize time draw range elements plus seconds equals to 0.1. If we do this all the way through, we can call each one of these. The reason why I do this is because even that the if statements are here, I prefer this stuff be put in a class type. But if we don't put it in a class type, I still like to declare a few lines here down below that's out of our if statements, because I feel like it does more for me if it's not in a class. That way, if it was in a class, I wouldn't have to worry about any of this. Okay, so just keep that in mind. These are our init and static voids to our new DLL. If we start is our actual, we have a start variable up at our method called thread start. We can start thread 1 and a value of 1 as our 0 and 1s would be equal to 1. Thread 2 is equal to 1, so all these are true values all the way down. And we do this the same method to draw thread 2. So each one of these, each variables have their own thread to task. So it's what I call simultaneously tasking, or this thread handles these GL functions. This thread handles the same GL functions that thread 1 handled, but thread 2's handling them too as well. So as thread 1 or draw thread 1 gets finished, which that thread gets finished, then it bumps to draw thread 2 and it continues the same process over. So I can skip the pause and then wait for the initialization and then resume to the next thread. I don't have to do that. I can jump simultaneously. One thread's over, I can just jump and do the same thing over again. That way I'm always staying high and stable performance and not having to jump frames around and cause a lot of video stuttering. That is the little kind of secret algorithm that I had in my mind, because I don't want a pause and resume in between each thread that gets called. I want this to go simultaneously, 1, 2, 3, 4, and so on and so on. So everything from the square down does this. We do have ones in classes. Let me see if I can find it, because I think I put, yeah, thread 9, thread 8, 3, 7, 6, 5, 4, 3, 2, 1. Yes. Okay, so okay, thread 1 is our D word. So this is our thread. This is our main threads we call from our handles. If we go on down, I'm going to show you where our classes. I did put some classes in here. I can't stand not coding without putting classes. You know what I mean? Like, it has to. So we have a class called threads. We have our integers up here for each GL function that's been called from that DLL. And we have a static void. Static allows me to access this completely within this class. If we had this just void, we wouldn't be able to access a lot of this within code. So static always helps. And it's the same thing as before. It's nothing new. It's the same shit. It's just we're putting these in our own class instead. And this is a little different because these don't exactly have the if statements. Well, they have the if statements, yes, but they also have individuals for this as well within the classes. Everything is simultaneously hard-coded. So I don't work on one thread, pause, resume, new thread. I'm wanting to simultaneously jump constantly. I don't want my threads to stop. I want them to jump constantly. Now, that is hard on the GPU. You're going to use a lot percentage of your GPU because of that. And it's not going to be as hard on the CPU. It's more the GPU, because these are actual functions from OpenGL that focus on graphics, textures, imaging, and so on and so on. So it's really complicated for me to actually, put these on one thread. There's probably another way of doing this. If I had access to the actual Quake Champion source code, I could pull this off. Now, you probably will ask me, how in the hell are you doing this without access to source code? Okay, this is where the fun begins. I like to show people this. So if we scroll all the way down, we have two other methods. One, we can do it this way. The other, we can do the other, but I choose to do it both ways. We're using a bool method, which is our inject executable. Okay, we have our two LP voids for address 1 and address 2. If you look, we're able to call the character set, which is through PC Quake Champions executable. This is the executable we want our DLL to inject. So if we go down, I'm not going to tell you what every bit of this does, because if you're a really good programmer, you're going to know exactly what I'm doing right here. So if you create the remote thread, blah, 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 nothing new. Within our int main function, our int main method, I call it int main method. We want to go down, and this is where our start up info A, and then our process information, our local variable of PI, and our local variable of SI. Zero memory of SI variable is size of SI, the same thing for PI, and so on and so on. So we're able to get the actual library. We're using the function load library A. So we're able to go system, and then that's where our DLL is going to be stored. So wherever our executable is getting injected, we are looking for in system, and then that's our subfolder, and then lag DLL. Same thing. We can call these addresses for wherever we have the addresses at. I like to put these in here. This is a test, so these are, I can't tell more info about this right now because, I just don't know for sure. But get window thread process ID. So it's going to try to find the window once the process starts, and then the executable inject with variable DIP, PID, variable SIPI, size of SI, size of PI, blah, blah, blah. Okay, now if you realized up above when we were calling those actual win APIs or bool win APIs and different methods, we're using handles. Okay, so we have thread 1, thread DD underscore 1, and draw thread double D underscore 1. Then it has a std cout, which is we're using IOStream library to pull this off to give us a printout, which this is not a console application. We could take this out, but I choose to use this anyway. And then here we call thread underscore 1 equals create thread. We give 2 null parameters plus a 0, then a comma to call another thread with a null and a 0 parameter. Nothing different, same thing all the way through for each and a one. Then we're calling a wait for single object of thread 1 is a variable or a parameter of 0. Then we use the same method down here, and then we draw everything else. So that's basically the sum of this code. That's how I'm pulling off getting some performance and stability boost. I'm putting all the GL functions in threads to allow me to control those. If I want to prioritize a thread, I could use a priority functions and stuff for multi-threading, where I could prioritize one thread to be for something specific. Once that's over, then the rest of the child threads can initiate and go through its own process. But we don't want to have that, because I've learned by testing that if we prioritize one thread and other childs, after that one thread's done, you have a little lag spike before it hits the next child thread. So I don't like that. I didn't like that when I tested it, so it was giving me weird kind of lag jump spikes. But it was smooth, but it was lag jump spikes. You could see them, and that was ugly and not pretty. So, but yeah, keep in mind there's one more method that you can do with this to inject the actual code into the actual DLL. One method here is we're going to minimize the desktop here, and we're going to use a hex editor called HexNeo. I'm going to go ahead and load it up for you. This is a good editor. If you're curious about it, go check it out. It's something really interesting. I use this to do a lot of hard coding, a lot of different things. So if I go to edit up here and I go to find a method called render, I'm able to take all of my code from my actual doings as well. So if I want to inject or insert some code into this DLL, and this program, once it's injected and the new code's in there, and I save it, it automatically sets up everything, sets up the registry. Everything's set up the way you would if you're compiling it in Visual Studio for the first time. It's a really, really, really nice tool. So if you go here, for an example, and we go to Documents, 2012, Projects, Lag, and we go up here, and we add our lag.cpp. We can add this in here if we want to. I've already added it in there, so I'm not going to overdo that. But we can add this code into our DLL. Once we do that, my program closes out. It's got a bug, but either way, you get the point. You go up to the save button and you save it, and it's already got it everything. You just patch the program, patch the DLL, whatever, and you're done. Nothing really to it, nothing major. So I thought I would show you this. Now, the next update is if you actually got a little insight, I am putting Vulkan support for the game. So you're going to have Vulkan support as well. I've took all the VK functions and the methods in there and putting them all in threading. I'm in the process of doing that. There was like probably 500 of them that I needed in there. But every time I go through, I do a little bit every time because it takes me around 2 hours to do one method. So if I go through that process and after I test, I'm always getting more and more better performance, more and more frames, more stability as I'm going. And I mean, I wasn't able to play on medium settings with a resolution scale of 100%. I wasn't able to do that. and I was able to do that just fine, and I was getting over 140 FPS. I never got that. Like, I was around 75, 80 tops. So that's a huge frame increase. So I'm really happy for that. And I encourage you to check this program out. Try it out for yourself. If you want to go follow the Reddit page, you just have to search for it. I'm not going to link it. But I'm super excited to bring the next update out. I want to kind of make a video on this. So thank you so much for watching. I'll make another update video on the Vulkan support. It uses the same algorithm methods I used here. Just a little stuff different that I did before that I didn't do. So we're going to see. Plus, I've updated this code a little bit in the new update. And wow, the performance I'm getting now and stability is really nice, which you've seen in the video. If it lagged or stuttered, it's not in game at all. I have my frame counter at the top right, so it was so smooth, so rewarding, and game just looks really good too. So, but anyway, thank you for watching, and hope you enjoyed the video. If you want to try out this build, the link will be in the description. You can go ahead and try it. If I've said in the video I wasn't going to release it, I'm just going to go ahead and release it. You can try it out for yourself. Just keep in mind, this fix could work for other people, but it may not work for everybody. So just keep that in mind. If you test it and you're not impressed, if you're trying to play this fix for high frame rates like 500, 600, 700 frames, it doesn't work that way. You want the game to be stable at any frames you're getting, whether they're 30 or 40 FPS. You understand? So if you don't have any video stutters, no game freezes, no lag spikes, no hit detection lag, anything like that, and you're at 30, 40 FPS, that's amazing, because this game is tailored to the high and ultra class PC users. It's not tailored to this mid and low class people. The game just can't run smooth on low-end PCs and mid-class PCs. It just can't do it. That's why I'm determined to fix this once and for all, which I'm hoping and praying id Software will fix that for low and mid-class PCs, but I have highly doubts that they will. Because their latest stream, they talking about it, was all they were saying was they were adding a bunch of gameplay changes. Nothing about performance was ever talked about. So really, I don't know. But we'll just have to find out when it released November patch. But anyway, thank you guys for watching. You guys have a wonderful night, and stay tuned for update number 2. And feel free to go down in the comment section and let me know what your performance was. If it was stable on low frames or whatever you could get, please, I really encourage you to go do that, because it gives me some feedback. Because I've already given this to 12 people and they absolutely fell in love with it. So I encourage you to give me some feedback, to say it's a little better, it's better, or it's a lot better. Just say those. I really appreciate it. You guys have a wonderful night. Later.